maybe. Yeah, where's the one? Maybe it was supposed to be done like this.
That's what we originally going to do.
But it doesn't say to bisect.
Are we creating EF now?
If the rectilinear angle is just BDA and CDA.
This is the one we're using. This is the one just.
Hold on.
She's on the floor. Can't you see her?
Whatever's dotted is just. Here you can.
You might have too much hypothetical going on up there.
Well, I like being hypothetical.
Because we have to either choose in between BA or DA. So one of them is going to have to go. We know that it's going to have to be parallel eventually, so we're keeping EF up there.
Students often come in with bad experiences or a sense that I'm just not a math person, or the dread of math class. A lot of people can relate to this. And what's fun for me is taking that and sort of turning it inside out, looking at everything that makes math difficult and challenging, and finding a way to turn that into a challenge that people want to engage, something that is fun to try to overcome. It's a riddle to figure out.
So how am I supposed to make an angle out of parallel lines? Challenging.
Fun and interesting way to learn geometry.
One of the keys that we always try to do is have inquiry-driven learning and teach primarily by asking questions. And that turns geometry into one big riddle that students are always unraveling.
So if we've got angle BDA and we want to create an angle equal to it, where would we want to create that angle?
Well, if it's a good question.
What do we want to have the vertex of our new angle be? The point in the middle.
We're using words, and I don't think we know what they mean.
That was a great moment with Jazz where she recognized, okay, we're talking about things, we don't know what they mean. I need to ask this. Let's specify. Let's get the definition right.
Vertex is where all the angles meet.
The point in the middle. So what's the vertex of angle BDA?
E?
Where do we want the vertex of our new angle? The one we're going to use Prop 23 to draw.
A.
At A? Okay.
And so it's great to see that thought process becoming almost instinctive for the students. So there will be classes where almost every sentence that comes out of my mouth is a question. And that, in turn, builds great habits in the students.
Is that where we complete the parallel line?
Yeah.
So write it to the left of A.
Can I just ask where the new line came from?
Oh, that, you mean FA?
23.
Wait, which line? A, E, or FA?
My role as a teacher is not to give answers, but to help students learn where to look for those answers themselves.
Yeah.
So AF came out of this part of the line right here. AF came out of Prop 23.
Careful. What'd you call that part of the line?
AE came out of...
Or AE.
Yep.
That came out of Prop 23. Then we extended AE to the left with post 2 to create AF.
Oh, it's like a puzzle.
It's like a jigsaw puzzle where you can start on the ends, or you can start in the middle, or you can go in any different way.
If you can't prove what's real, then is it really real? If you don't have evidence, then how can you believe that it's true?
So yeah, being the literature guy, the first thing that I started off with, of course, was stories. I asked, okay, what are stories that we can tell with mathematics?
Who is the hero of the story?
The triangle.
The triangle.
Oh, mine too.
I had postulate and definitions as.
Ah.
My hero was Sir Dot.
Sir Dot.
Sir Dot. Sir Dot, Lefty, Righty, Bob, and Miss Infinite.
We looked back at creation myths. We looked at the first chapter of Genesis, and at the Greek myths, and also at some African myths, at Norse mythology, which a number of the students had read the semester before, and looked at where in all of this is there a mathematical foundation.
The person who's doing all this stuff is some higher being or...
Oh, these are all the playthings, lines and particles and triangles.
Yeah, it'd be cool if the whole universe was just being made.
The student.
The students, the higher being drawing all of these things. You guys
Me!
are the hero of the story.
I'm the god of the pencil.
So what's the quest? What's the arc of the story?
It's to make a stable universe.
No small project there.
Yeah.
You
And
sure
you know, if
everything
you
makes
don't know
sense?
what you're doing,
Everything can be proved.
yeah, like everything makes sense, like it can get through. The cookbook of how to make things.
Is this a cookbook? Mythology is always about explaining how the world works. And that's exactly what mathematics is designed to do as well. And so when you start seeing a story, a narrative with characters in mathematics, then it becomes much more engaging. Then you start realizing, okay, these aren't just arbitrary numbers and shapes and functions. This is a quest for knowledge. This is trying to seek out an explanation for why things function the way that they do. What is the water? We went back and did all those creation stories, right?
Yeah.
And they all took place and there was water to start with. What's water here?
It's the most basic element.
The paper.
Oh.
And so there was nothing on this paper. And then there was
A point.
a point. And from that point there came
A line.
a line. And from that line.
Another.
And so we create all these elements of the universe. All this has happened before and it'll all happen again.
Yeah.
So technically I was right with the paper.
Absolutely.
Awesome.
That's a lot more engaging than solve for X, as far as I'm concerned.
We're learning about the origins mainly. How we came up with geometry.
When you make a mistake, a stable universe?
No.
No.
No, it becomes unstable. It becomes
Wow.
absurd.
Dang it.
How will you know when your story reaches its end?
Boom.
Pretty much so. There's no more universe then.
I mean, if you're making a stable universe, the end would probably be more like, hey, nothing broke, so
So it's all here now.
yeah, everything's okay.
We're learning Euclid's Elements. We're on book 1.
It all started with a triangle,
It all started.
and then it
What do you
went.
mean? Like,
We first started with making a triangle, and it just got more complicated.
Going back to kindergarten.
what does that mean?
Okay, so we're doing it through Euclid, and so typically I'm used to math dealing with a lot of numbers, but with Euclid it's a lot of logic and problem solving more so. There isn't like a strict formula that you give in on how to do this. You have to figure out that formula on your own.
There are 5 common notions, and then we got the definitions, and then we got the postulates. And usually on the given, it has like a line from point A to B, and that's like where you start. And then you have to figure out what postulates or definitions or common notions you have to use in order to solve the entire puzzle, which is to put like the proposition together.
At first we thought it was going to be like, oh, this is so hard. And now that we're looking back at those old ones, it's just like, well, those were easy.
Instead of getting taught a lesson and then being given a paper, we get proposition 1. So you had to use the definitions, the postulates, we had to create a triangle using a line, and then we used 2 circles. You actually get to teach yourself in a way that makes you remember it more. So you can take it at your speed, and you don't have to do it in a very set way.
It presents geometry in such a clear, sequential order. Everything builds on what you have already learned, on what you already know.
The propositions help us to move forward with each other one. Like, if we do one, and then the next one we do, we can use that one to help us with the other one.
You have to use your knowledge to follow certain steps and create it as you go.
Eventually, when you get to like the end, all the propositions are mostly going to be used in order to solve that one proposition.
It gives anyone studying it the opportunity to become the expert in geometry, not just to be able to pass the test or to get to the next class, but to actually understand what's going on and how it works.
We had to team up in groups, and then we got to teach the class, which is something we've done twice. And before this school, never.
So we're using this angle and we're adding it to GHD, which if it's less than AGH, then it can't equal 2 right angles.
Like, pretty challenging one for homework the other night, and I was like, oh my god, this is so hard. But then when we go over it in class, I really feel like I know what's going on. Because like I have other people who are there just like back me up and help me with that.
That we're kind of all at a point where we can all kind of look at it and understand what we're doing.
But if you already have 2 angles, how can the sum of both be less than 2?
When they recognized, oh, my classmate's up there, I'm struggling with this part, they didn't just jump in and correct what was going wrong. They figured out how to ask the questions themselves. They started playing that inquiry-driven learning game, leading their classmates to the right way to teach.
You need to make sure that it is what it is. You can't just say, hey, this is it, and go on blind faith. You need to do the work, say that, yes, this is what I say it is, and make it very concrete that, yes, this does work, and yes, I can show you and essentially teach you, anybody else, how to do this.
And that's a skill that they can apply in science, in literature, in history, in anything they do in their lives. At the end of the semester, I gave the students a little sampler of some of the really mind-bending things that happen when you start to break those rules, when you say, okay, what if we're not on a flat surface? And so you get some great stories from Lobachevsky and Gauss and Bolyai. And so there was a lot of mind-bending, a lot of groans and banging heads against the desk as students realized, wait, everything I know is wrong, which is always a lot of fun.
Oh, Flatland!
A little bit. You know Flatland?
Yeah, I saw that.
You saw the movie?
Yeah.
You ready for your first sight recognition lesson? What do you see when you look at me?
A square.
Is that what you really see?
Go
on.
A line.
Is that all?
Is there any reasonable explanation for what Flatland is? Or is it you have to see it to know what on Earth?
Minecraft Flatland. It's a see it to know.
Mostly it's a see it to think about it.
A world that is two-dimensional called Flatland. One of the characters from that world, a square, meets someone from a three-dimensional world, a sphere.
3 to the 3rd power has an obvious meaning.
What is that?
No, a line. It's a circle.
I'm no demon. You were right the 3rd time. In a sense, I am a circle. A circle more perfect than any seen in Flatland.
But wouldn't his body still be 3D? No, his body would be 2D, or at least it would be
The part that they can see is
because
2D.
their eyes can only see 2D.
Right.
Hey, we talked about this before.
I'm mad. I'm insane. What have you done to me?
Lifted you out of Flatland into reality.
And so we got to end with a really fun demonstration of how what you can see can teach you to prove the kinds of things that you can't necessarily see. It's also just a really fun, goofy story that helps you visualize mathematics.
I think it's very fun getting to that point and constructing a shape and layer. It's just very fascinating. I think it's very fun.
Creating a rectilineal angle.
Face my rectilineal anger.
Equals